to check if each group is normally distributed. Now, wasn't that construct a QQ plot?
Yeah.
Okay, so that's 5. And then 6, we assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest variance.
Wait, what was 4?
Well, let's see, 4.
4 is the first and the third.
Okay.
Yes, means they're all. Oh, wait. The data in each group are normally distributed. And sample means are all positive. I don't think the variances aren't all equal.
That's what I thought. I thought it was 1 and 2, but not 3.
Oh,
1 and 2, but not 3. Yeah.
let's do that.
Wait.
I'm going into the textbook since we're
Okay,
not
so
sure
it says
about
the
it.
requirements for A and OVA. It says the data are normally distributed and that the variances are equal for each group. It has absolutely nothing to do with sample means.
Oh, okay.
Well, actually, but it's still, well, no, all of it would be right because the p-value.
No, it does, but the sample means are all positive too, huh?
Yeah, so it's all of them.
Are equal in each group. Okay, well that's good to know. So I thought the variances weren't equal because really because what about that one that says that the variances can't be, let's see, what does it say? It's number 6, I think. All right, we assume the variance in each group is the same if the following happens. Oh, so I guess the largest variance is less than 4 times the smallest variance. Okay, so that makes sense. So we just can't run an ANOVA test on it if that isn't true. That's right?
Yeah.
So that just means that they don't have to be equal, but we just assume that they're workable if they're at that point. All right, so then you got samples for 3. There are 2 pairs. How many pairs are there when there are 6 samples? And said that's 6?
Your mic keeps cutting out. I didn't understand most of what you said.
What is that sound? Now it's gone away. Okay, so I'm on question 7. An ANOVA hypothesis test is equivalent to conducting 2 independent sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples?
6 pairs.
6 pairs. Okay. The way you guys work that out. The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. Oh, I think I did these.
Okay.
Okay, soccer shoes. Okay, I did that. 5 types of shoes.
For number 8, I got 19.
Okay, I need to get my data in there. The column accuracy of the distance. Answer the next 5 questions.
You said 19, Joseph?
Yeah. As long as I'm looking at the data right.
Okay. Sorry, I'm still have to get it.
Well, I'm going to be there in just a second.
Okay, so here's what I got.
Open data.
So it says what's the lowest minimum for them?
It will contain your data into the dependent and the footwear code into the factor. It's okay. All right.
I got minimum of 19, maximum of 48.
Oh, shoot. Hot dog nutrition, that's not going to help much. Okay. Okay. Open
Fudge.
data.
Hold up.
I thought this was kind of fun.
Descriptive means plot.
So do we have to transform with this? Probably, to automatically recode, because we've got those codes that are...
Ho ho ho. There we go. Wait a second. How'd you get a minimum of 14?
I got 19.
Oh, okay. Minimum of 19, maximum of 48?
Correct.
Okay. All right, cool. Let me go back. Okay. The test for equal variances is satisfied for these data.
Yes.
Yep, that's what I got. Okay.
3. And then number 11, I got true as well.
Yep. Okay, so 12. Perform an ANOVA test in SPSS and observe the p-value is 0.081. Then remove the stocks data and perform the test. Again, so what is the p-value when we remove the stocks data? Sorry. No, stop.
So what was the question, like question 8? What was that first one where it was 19 and 14? Where was that?
The lower is 19. The upper is, or minimum is 19, maximum is 48.
And that's about, let me see where that is. So what was that asking about? Oh, minimum, maximum. Oh, so they wanted to know the lowest, and the highest.
Mm-hmm.
48.
Okay.
Now, do you guys have a system for when there are questions on the test so you're not going back and forth between your data? What do you do to make that go a little bit more smoothly? Or do you just go back and forth?
I just go back and forth.
Like, are you talking about when there's data on the screen that you need to?
No, I'm just saying, yeah, rather than going to the quiz, reading the question, going back to there, although I have gotten before over when especially when I had a couple different files open, So maybe it's better. I just didn't know if people had luck in making notes about what they're looking for, and then, but if everybody's going back and forth, then
Yeah, that's what I'm doing.
that's probably the best.
Okay, I don't understand the
How do you
second.
remove the SOX data?
Give me a second. I'm just getting into SPSS, but it still doesn't look like it's working.
Did you guys actually do the QQ plots?
Yeah.
Yep.
And do you have, like, what do you look for to make, I missed that question on the last exam. Just don't want to miss that again. I'm afraid I'm going to miss that again and not be able to figure out what's normal. So what do you guys look at? What is your...
The straight line. If it's a straight diagonal line, it's normal, right?
Yeah.
I mean, sometimes it goes a little bit
Well,
side and then it's still okay. And
as long as it's not a vertical line. Okay.
Okay, I don't know how to do that second one. Or the figuring it out without the soft.
Yeah, I don't know how to do it without the SOX either.
so that was, I wonder if that's in our individual prep, because there is something that file is used for that. Does it show us what to do with that? Let's see.
Well, there isn't any socks data. That's the thing. All of it is either shoes or.
I thought I saw box data. I thought I saw it.
Yeah, there's SOX in there.
I saw,
Where?
yeah, I thought I saw socks.
At the bottom.
Okay, let's see, because I know it's in this.
Oh, okay.
But I
So
don't know.
we want to get rid of 6?
Yeah.
Oh, crap. How do you do that?
So this says
I'm just going to delete it out of my thing and then reprocess.
That's one way to do it.
What did you do?
I'm just deleting the SOX part out and then I'm going to reprocess it.
You mean you're just going back to your data and just taking it out?
Yeah.
Erasing it. Oh.
Because we're not going to be using this data anymore. It's the last question we use the data for.
Okay, so this says worked example soccer shoes. Let me just look at that really quick. Yeah, it doesn't have anything about taking it out.
Oh, I can't remember where to look for the probability at.
No. So it doesn't ask us to do that. I thought I had worked those. So how did that work out, Joseph?
I can't find the probability. I don't know if I'm just looking at it wrong.
It's very nice to see you. You too. Thanks. Thanks for having me over. And nice, man. It was great.
Okay. Let's do.
You
Uh,
loved it! No, I'm sorry.
Sorry, my roommates just got back, if you can't hear.
Oh.
Okay. I got 0.309.
Okay, yeah. I don't know why I was looking at that and it wasn't making sense, but it makes sense now.
That's interesting. To take it out. Okay, so let's see what I get.
Yeah, so just delete it out. Because we're not going to be using that data anymore.
So you had to go ahead and transform the data again.
No, I didn't
No,
finish for it.
it's already done.
Yeah, I just deleted it.
So, wait, so did you get .309?
Yes, I did.
Okay. That's what I got.
3.309.
Yes.
Okay, so let's see. So what was that asking for? The was asking for the
Key value will you
yeah.
remove the SOX data.
Okay.
So, okay, and then 13 I got right.
Okay.
Yeah,
309.
$3.
Okay, I got that too. Okay, excellent.
Okay. 14. My goodness gracious. Okay, I gotta switch ones now. Excuse me. Oh goodness.
Ooh, there are 18 questions. Well, we're actually making pretty good progress, though.
Yep, we're cruising.
Okay, let's do. Man, I should have done this before. Free code, type, code, code. Okay.
Okay. Oh, 13. Is that what you guys are doing? So it's to the right of the F statistic.
Correct. Yes.
Okay. All right. And you guys have moved on. I'm just slow.
All right. Oh crap.
So do
Which
you
one are
think
we doing first?
do you think they're going to ask us to do QQ plots on the exam?
Probably.
All right.
Examine the calories first. Okay, I can do that. Dang nabbit, I did it again. Ask me later. Gone later? Where are you going? Oh, yeah, no, you can have some. Well, it was meant for all of us. Okay, sorry. Ah, man. I gotta remember to do the options.
Oh, yeah. That's interesting, isn't it? Because it really doesn't have anything there without the options. Oh, so how come it didn't have options to... No, never mind.
Oh, man. Okay. So, means of calorie. It is. What are we figuring out? Sorry. Let's see.
So that's what I find is hard, is that I get there and then I think, okay, so what am I looking for? Okay. So did you guys do the QQ plots already?
Yes.
And how do they look?
Like a QQ plot.
Doing them. Huh?
They look like a QQ plot. Sorry. Should. Yeah, I need to stop. Okay.
It says compare the variances.
Oh.
So the variances are the standard deviations squared, right? Of course.
I did something, let's see, analyze, descriptive statistics, QQ plot.
So those are, so if they're all the standard deviation, they're all real close to each other. One of those is not. They're all within 4 of. One of the lowest isn't 4 times less than the highest.
Great, but
Analyze QQ plots. Okay, so the next question.
oops. Explore, that's what I want.
I guess I better do a QQ plot. Now, does this information pop up on, is there a place where we can do the QQ plots at the same time? We have to do them separately.
You should be able to do it at the same time, I believe.
That would be helpful. Okay, so then that doesn't look like it's, that looks to me like the first one does not look normal. Because it's on either side and so does the first one look normal to you guys?
Holy smokes.
Because it goes on either side of the line with. What do you think, Joseph? That first chart, do you think that looks normal?
I'm still looking at getting mine do its thing.
Okay, so, okay, trended. We don't want to do that one.
They all look relatively normal to me.
Even though that's going on one side and the other side of. Now all I'm getting is in one plot. Oh, because I'm just doing calories. Because I'm just doing calories. Is that right? So that would only come up. I would only need one of those.
Yeah, I'm gonna say it's not normal.
Because it does seem like it's going on either side of the line, and I thought that was like the kiss of death.
Wait, which one are you guys looking at?
The normal QQ plot of calories.
Okay, for what meat?
Well, I just did it all for calories. But you did them individually?
Yeah, and they all look normal to me. I mean, so the thing is it's not going to hit perfectly on the line. That's the thing.
All right, so let me see. So how did you, let me see if I can figure out
So
how to.
14 should be the first answer, right?
So calories, ooh, but how did you get the, so I'm on this screen for QQ plots, and I don't see how to get how do I get the different kinds of meats to show up? All I see is sodium and variable code.
Okay,
so
I put, okay, so I did it, want to explore, correct?
Yeah.
And then I put in the dependent list calories, the factors list type, and label cases by type code. And then I clicked plots.
Oh, all right. So I missed a step. So do you mind saying that again? You went to analyze. No,
I went to, yeah, analyze,
analyze
descriptive statistics,
descriptive statistics.
explore,
Okay.
and then I put in the dependent, I put calories. In the factor list, I put type, and in the label cases by, I put type code. On the side, I clicked plots, and then I checked the normal plots with tests.
Oh, wow, thank you.
I clicked continue,
Okay.
and then OK.
Okay. All right. So let me, because all I came up with one is because I didn't put anything else in there, so I need to fix that. Analyze descriptive statistics. Oh, okay. Because I went right to QQ plots. So calories. And then under factor list, what did you put? The variable code?
Okay, so
What's in the factor list? Ooh, I'm glad I'm learning how to do this.
Factor list, I put type.
Oh, type. All right, so I haven't recoded. Shoot, I didn't recode the type. Now, type variable code. Uh-oh, I'm not able to do that. I must have already done variable code. Oh, never mind. Well, why? What happened? Variable. Is that what you said you put? No, you put type in there. Why isn't type coming up in my list of things to be able to do? Uh-oh. Transform. Yeah, so I don't have type in there. Why do you?
What'd y'all get for 14?
The first one.
Okay, that's what I got.
It could be wrong though, I will admit that, but it looks normal to me.
Okay. Oh, shoot.
Okay, and then 15, I got the second one. Or I guess 16. Alright.
For 15 or 16?
15, I got the third one. 16, I got the second one.
Okay, that makes sense. Okay, the second one makes sense for 16.
Hmm.
For 17, I got 0.179.
Yep, same.
What did you get? 17 is what?
0.179.
Okay, I'll check that. Okay, so I couldn't get it to come up with more than one QQ plot, so I'm going to have to work on that and see what I'm doing wrong.
And then I got the first one for 18.
Yep.
Did anybody get 18?
No, I got the first one for 18 as well.
Okay. Okay, we got 18 wrong.
You got 18 wrong?
16 wrong. 15
16.
wrong.
16 and 15 wrong?
Yeah.
Just those two?
Number 9 is wrong. Number 8 is wrong.
Holy smokes, okay.
Okay, let's see. All right, so 6.
Number 4 is wrong.
Wow.
Maybe you guys were right for that one.
Okay, so 17 is wrong too.
No, 17 is correct.
Oh, 17 is correct.
So 8 and 9 are wrong.
Yeah.
Okay.
Let's see what those
Number 4, it says we got 2/3 of it right. So marking all 3 is wrong. One of them has to get unmarked.
I think it's the first one that has to be unmarked.
Okay.
Okay. So and how did we get that one wrong?
So number 4 is wrong.
Yeah.
Well, because it has to be that the sample, I mean, the only requirements are that the sample means are all positive. Well, no, maybe you don't have, maybe that's not it.
Yeah,
That's why I'm just wondering if it has to be positive. I'm just trying to find that.
Because
So the first one,
there's something about there that something has to be positive, but maybe that's just what happens, and that it's not one of the
it's not one of the requirements.
one of the requirements.
Wait, variance.
What are those things? You said that 8 and 9 are wrong?
Yeah, I don't know what else it could be.
So it says variance.
Oh, the smallest variance for the 6 groups.
The two requirements for ANOVA are that the data is normally distributed in each group and the variances are equal. So it doesn't have to be positive.
First one, how many have you had?
2.
So what is it that it says? It says something about positive. I was going to go back and look and see what that said because maybe it just said
says
all
here that
values for the F score score, maybe it's the F-score that's always positive.
Oh yeah, it does say the F-score is never negative.
Okay.
It says that, but it says the requirements for ANOVA are that they're normally distributed and the variances are equal.
But the one about the without the shoes was right? I mean, without the socks?
I think so.
So maybe we didn't get the variance. Mean the standard deviation. Oh, I know what it is. Because the standard deviation has to be squared to be the variance. But that doesn't make any sense, though. They would still be the lowest value.
Okay, so for 18, or for 8, I got 27.207.
So what? So you went ahead and squared it?
Yeah. So I squared
how
the
could that be?
smallest.
27 point what?
207.
Okay. Let me see.
That's for number 8?
That's what I got.
Oh, God. Oh, okay, because that's what we looked at was the minimum and the maximum, not the standard. We didn't square the standard deviation.
Correct.
Okay.
So I just squared the standard deviation of the smallest one and the largest one.
Okay, so that's 5.2, 5.261.
No, 5.216.
Oh. 0.216
Squared.
and then 7.291.
Squared, yes.
Okay.
That's what I did. That's what I got. So I don't know if y'all agree or what. But
Well, that's got to be what it is because that's the variance is the standard deviation squared. So yeah, it's got to be that.
okay.
Got to be that.
So did we get 14 wrong?
No.
No. Okay, 15.
Yeah. What was 9?
9 was 53.159.
Okay. So we got to do 15, 16, and 18.
Okay.
53. 53.159. Sorry, I'm just
Yes,
trying to
53.
save myself. I know how to do it, but it just saves me getting out my calculator.
53.159.
What?
53.159.
Okay, I got that. And then it's 27.207.
Yes.
7.207.
Those are both correct.
Okay. So,
So did you say you resubmitted it?
Yeah. I still got 16 and 18 wrong.
did you
That's
get 15 right?
Yeah, I got 18 and 20, so as long as 18 is not C, or the third one, and as long as 16 is not the fourth one, you guys are down to three choices for those. I'm going to head off to bed.
Wait, what was 15?
All right, good night.
15 is the fourth one.
The fourth one?
Yep.
Okay. Alright, and as long as 16 is not the
fourth one.
fourth one? 16 is not the fourth one.
Let me double check that. Oh, I exited out. Uh-oh.
So it's not the second one or the fourth one.
I would like to verify, but I clicked off it and I can't look at it
Okay,
anymore.
okay. Yeah, I think it wasn't because I marked the second one the first time. So if it's not the second or the fourth.
Alright, I'm gonna get some sleep.
Okay. All right. Good night.
We'll see ya.
Good night.
I think it's kind of nice that he needs to get going because it kind of does move us along. So I am so slow.
It's okay.
I mean, I'm thinking that. Oh, so did he get 15 right? Oh,
Yeah, he got 15 right. 15 was the fourth one,
the fourth one.
is what he said.
All right, so we have sufficient evidence to claim that at least one of the hot dog types has a different mean number. So then that means that we rejected the null. So let's see if that helps.
So now the sodium levels construct.
Okay, so, well, 10,000. So, oh, well, but 7 times 4 is still, the assumption's been made.
I think 16 is the first one. Did he say that we got 17 and 18 wrong?
Yeah. 17's right.
So,
0.179 is right.
yeah, so he said that one was right. And so it's just 18 that's not C, and it's not, so it's not C or not A.
We do not have significant evidence to reject the claim that all three hot dog types have the same mean sodium levels. So I think it's the second one for 18.
Okay, but, oh, because now you guys went and reworked it for sodium as well as calories. And so the sodium, well, let's look at this. So that is the correct, so 0.179, whoops, now that's higher, 0.179 is higher than alpha. So then we keep the null.
Correct.
Okay, so we fail to reject. And then it's asking,
We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same medium sodium levels, which is the null.
right.
So I'm going to submit this and see what we get. Okay, we got 16 wrong. That was it.
All right, so let's see what 16 is.
So what did you put down for 16?
Well, I have not constructed QQ plots of the sodium level. So,
Okay, so it's not the first one.
what?
It's not the first one. It's not.
Not the fourth.
It's the 4th one?
No, he said it's not the fourth, and
Not-
I think he also said it's not the second. So I
Yeah,
think
I
it's
wrote-
the third.
It has to be the 3rd then, yeah.
Okay, so let's see. The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. Now, well, because I guess we can look at the standard deviation and see that they're within the 4, but that almost seems like sodium level for each of the 3 types of hot dogs. Okay, well that's probably what it is. Okay, well I'm just going to go ahead and submit it.
All right, guys, have a good night.
Okay, you too.
Good night.
Okay. All right.